right, in this video we're going to talk about more congruence theorems, and it's going to be angle side angle, angle angle side, and hypotenuse leg. The first one we have here is angle side angle, and we want to remember that we need to go based off of what we know in the triangle, what is given to us. So in this case it says that if two triangles and the included side of one triangle are congruent to the same thing in another triangle, then we can assume these triangles are congruent by the angle side angle congruence theorem. And I like to label, like here I have an angle, here this shows a side, and here is another angle. So that's where I'm getting my letters: angle, side, angle. Okay, same thing with the other one. I have an angle here, I have a side that follows, and lastly, I have another angle. So again, that angle, side, angle. They have to be consecutive. They have to come in that order. And so that's how you know which congruent theorem you're going to be using. Then we have angle, angle, side. And again, it has to be consecutive. So in this case, I have an angle followed by an angle. There's no side, this side right here, even though it's between the two angles I'm talking about, it's not marked, so I'm not going to call it angle side angle, for example. So it goes angle angle, and then my side is labeled, so that's how I know it's an angle angle side congruence. Same thing over here, we see an angle, and then a side, so it's angle angle side. The difference between the second one and the first one is the side is sandwiched between my two angles in the first example, where over here my side is at the end. It's after the two angles are labeled. And the last theorem we have here is hypotenuse leg. In the hypotenuse leg theorem, it says that if we have two right triangles and both legs are congruent to both legs on the other one, then we have a hypotenuse leg. So think about the name of this theorem. The hypotenuse is labeled and one of the legs is labeled. Again, the hypotenuse and then the leg. Remember that your hypotenuse is always across your 90-degree angle. Okay, that's how you know that's the hypotenuse, and it's going to be the longest side of a triangle. All right, so let's get started with some examples. The first two say, determine whether each pair of triangles is congruent by angle side angle, hypotenuse leg, or angle angle side congruence postulates. So again, we have to go based on what is given to us and go in that specific order. So looking at this first one, these two triangles, they're split up, but they share this side. So if I'm sharing the exact same side, I can assume that this side for both of them, if I were to split them up into two separate pictures like this, I can assume that these sides are congruent because they're sharing the side, so it's the same measurement. Okay, so I have a side in the middle, and then on this triangle I have an angle and then another angle. Okay, and this one, same thing, I have an angle, this is the side that it's sharing, and then my other angle. So if you label those angles and sides in that order and you consecutively read them, in this case angle, side, angle, that's how you know that this is by the angle, side, angle congruence postulate. That's your answer because we're given an angle and included side and then another angle. Over here, my picture, I also have a shared side here. Okay. Here I have a 90-degree angle that's labeled for this picture. However, it's not labeled over here. But because I have a straight line down here, I can assume that this is also going to be a 90-degree angle for my second triangle. So labeling these, this is a common side they share. This is an angle, it's a 90-degree angle. And this is also another angle that is labeled. So again, if I'm reading it in that order, I have angle, angle, side. And a common mistake here is that originally, just because this is a right triangle, it doesn't mean it has to be hypotenuse leg. The hypotenuse leg theorem here does only work for right triangles. Okay, only right triangles. But just because it's a right triangle, it doesn't mean it's automatically that one. So you have to be careful, pay attention what they're giving you. In this case, for example, 2, they didn't say anything about the 2 legs. So I can't just assume it's hypotenuse leg. Okay. Going on to number 3 here. So number 3 says, which conclusion can be drawn from the given facts in the diagram? Okay, so this diagram, you have to assume for these pictures that nothing is really drawn to scale. And we do this on purpose so that you're actually understanding what's congruent, what's not congruent, and so on. So in this picture, I have that these sides are congruent to each other. Okay, so perfect. This side is equal to this side. And then I realize that these angles means that these are actually also congruent. And if you remember, what we know about triangles is that the congruent angles means that the opposite sides are also going to be congruent. Therefore, this side and this side are congruent as well. And lastly, I have this mark that matches this mark on this triangle. So all those sides are congruent. So even though it doesn't look like it, by using the transitive property, all of these 4 sides in the triangle are congruent. Starting from the left or the right, however you want to look at it, those marks tell me that these sides are congruent. So let's look at my options here and see which one we can say yes to. So TQ bisects PTS. Okay, so PTS would be here. There's nothing about this that says it's bisected. There's no marks showing that the 2 angles are congruent or anything like that. If there was something here like this mark and this mark, then you could assume that they are congruent. But there's nothing again in the picture showing me indicating that they are bisecting or cutting it into 2 equal angles. So that's not an option. Next is that TQS, so TQS, this angle, is congruent to RSQ, this one. Or sorry, RQS. Let's go back and do that one. RQS is this one. So again, nothing showing, no marks are showing me or measurements that those 2 angles are congruent, this one and this one. So that's not going to be it. Next option says that PT, this one, is congruent to RS. And originally we did show that because this side is equal to this side and the corresponding angles make this one equal and this one equal, then I can assume that these 2 segments are congruent to each other. Given the triangles below, what information is needed to prove triangle ABC is congruent to DEF using the leg angle congruence theorem? So leg angle means we need to label a leg and an angle. Okay, so what information do I need to know? Well, the first one says that I should label AB is congruent to DE. The second one says that I should label AB is congruent to DF. The third one, C, is saying that BC, this one, should equal EF. And then the last one, AC should be equal to DE. Okay, so there's 2 already that aren't really making much sense. If I label that AC is congruent to DE, first of all, one of those is the short leg and the other one's the long leg. So that really, that's not going to show me that they're congruent to begin with. The other one that was kind of like that is B, because it's saying AB congruent to DF. Again, one's the long leg, one's the short leg. So that's not going to work. In order for it to be the leg angle congruence theorem, I have to make sure I'm labeling a leg, okay? C tells me to label the hypotenuse. So that's not going to work. And therefore, if I label my option A, which is AB congruent to DE, those legs are corresponding. They're both between the marked angle and the right angle. Therefore, we would be using leg angle congruence theorem. Okay. on to 5, in the figure, identify which congruent statement is true, then find measure of angle TYW. Okay, so let's look at this picture and see what it's telling us. This picture is saying that we have two right triangles, essentially. One's here, and the other one's kind of reflected across that line here. These sides are congruent, this one and this one. I can also assume that because they share this line, that part of the triangle, that's going to be congruent as well. So already, the hypotenuse here is congruent to each other because they share the hypotenuse, both of them. And one of the legs is going to be congruent. So look at that. I have hypotenuse leg for all my options. Okay. Because this is a congruence theorem, I can assume that both of these triangles are congruent. Therefore, these corresponding angles that they're pointing at are also going to be congruent. So I can actually set this into an equation. 6x minus 26 equals 2x plus 6. And I'm going to go ahead and solve for x. So first I'm going to move this 2x over. That gives me 4x here minus 26 plus 6. Then I'm going to add 26 to both sides. Oh, sorry, this is supposed to be equals a positive 6 in that previous step. So these cancel out here. 4x equals 32. My last step is to divide both sides by 4. And I get x equals 8. Now please note, it's asking me to find angle TYW, okay? So I need to go back and substitute into my equation. Now TYW, let me clear my picture here so you see where TYW is. TYW is right here. It's asking me to find this angle. Either way, I have to substitute that x value into this equation. Okay, so I'm going to go ahead and do that. So I have 6 times 8 minus 26. 6 times 8 is 48 minus 26 gives me 22. Now, if I'm not paying attention, I can already see that they're trying to trick me and telling me TYW equals 22. That is not what I'm being asked to find. Okay, I need to be careful here. So it's asking me to find this angle over here. So I know this is 22. I know this shows me 90. And I know all triangles add up to 180. So when I do 90 plus 22, I get 112. And then I have to take 180 minus that 112. Okay, so I get 68 degrees. And that's how much this angle is going to be. So 68 degrees is my answer. And then making sure that if I also go back and look, my congruence statements are a little bit off. Make sure that the corresponding angles are true. So like angle W should be corresponding, should be the first letter in your statement. T should match with X. So T is the right angle, X is the right angle, perfect. And then the last one, Y should match with Y because they're sharing that same letter. A and C had those congruent statements wrong anyway, so that's another way that you can cancel that one out of your options. Okay, going on to number 6. Which of the following sets of triangles can be proved congruent by angle, angle, side? So again, go back and label these pictures, see what information you are given, and see if that's angle, angle, side. So here I have an angle and then a side and then another side. That is not angle, angle, side, so it's not going to be A. Here I have an angle, and then a side. That's good for me. Let me make sure that it follows the same thing over here. I have an angle, and a side. Okay, so B in this case is going to be my correct answer. Just to double check, I would go through and like if this was the last option, obviously, but it helps to write them angle and then a side and then an angle. That's angle, side, angle. This one's angle, 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 which is not one of our congruence theorems. Okay, last one. In the figure, angle H is congruent to angle L. So I'm going to go ahead and show that these are congruent by marking them. Okay, angle H is congruent to angle L. And I also know that HJ, so HJ is here, is equal to JL, this one. Which of the following statements about the congruence is true? So I only have an angle and a side here. An angle and a side, an angle and a side. Now this is kind of going back to a few units back when we talked about special kinds of angles that are across from each other. Okay, they are vertical angles. And vertical angles are always going to be congruent because they're across from each other. So this means I have another angle here. So looking at my letters, I have an angle, a side, and an angle. An angle, a side, and an angle in that order. Therefore, I can say that my answer here is A.